Hi all you cool cats and kittens, it's Carol here. Just kidding, it is your instructor, April, but we are here starting our Paradise Path along the Paradise Creek. So your first question, once we get kind of up closer to the creek, is going to be question 1. So I'll kind of get up in here for you. Alright, so you're trying to describe the vegetation along this stretch of the river. You can see a lot of new growth coming in. So is this old or young growth, dense or sparse? Does the riparian environment here look natural or artificial? So the riparian area is simply the vegetation along either side of the river. Also, question 2 will be answered here. So you have to describe the water level. Can you see the water through the vegetation? Is the water high or low? Is the water moving fast or slow? Also answered question 3 here. So it's just talking about how the water level in Paradise Creek fluctuates greatly depending on the season. 3 months from now, so that would be mid-July or so, do you think the water level would be higher or lower than it is now, and why? Let's think about seasonal changes, if it's drier or a more wet environment. Just a little bit. They're kind of up alongside these abandoned tennis courts. So we're coming up onto question 4 here in just a minute. Alright, so we are going to be looking down and up the stream along the bridge here. So here's some downstream footage. So our questions for this part: does the creek appear to run a natural course or does it look artificially channeled? Alright. Describe evidence that supports your decision. So is the river more narrow? Is there artificial rock? How dense is the vegetation? All that type of information is going to be evidence for your answer. So this is upstream here. All right, we'll keep walking. Alright, so we're looking at the vegetation along the river on this side as well. Alright, so it's a bit more open along here. Right? Vegetation isn't nearly as dense as it was when we were answering our first few questions. Also, what does this indicate about the channel? So is it artificial, natural? like that. Feel free to pause the video as well to answer these questions, and we'll just keep walking. Going to be coming up to questions 6 and 7 here. All right, so we're going to be looking up and down the stream again. So here's downstream. So the question for this is asking, does the stream flow smoothly down this stretch of the creek, or are there ridges and falls? So here's the downstream part. And here is upstream. Okay, and we're also answering question 7. So from the bridge, does the creek appear to run a natural course, or does it look artificially channeled? Here's downstream again. Compared to the upper section of Paradise Creek, how has the channel changed? And for question 8, what you're essentially doing is measuring the width of this bridge. So clearly you guys can't do this heel toe measurement. So if you go to page 203, at the top of the page, there's a table that has a blank spot for Paradise Creek for width. All you have to do is write down 2 meters. So the width for Paradise Creek is 2 meters on page 203. So you don't have to worry about question 8 after you write that down. All right, and we're gonna keep on walking. To question 9 and 10 here. So here it says to walk down the path until you are across from a large concrete culvert. So that's what that is across from me here. And Paradise Creek used to run under the street here, channeled to go entirely underground. So the stretch that we just walked is the last of the old channeled stretch of Paradise Creek on campus. And so we get to see some restoration efforts of the creek. So it's clearly been redirected to not go under the road now. So what type of evidence of rechanneling can you see from here? Question 10 is about what types of plants are rehabilitating this stretch, and are they similar or different from the established vegetation that was further upstream that we saw earlier? Feel free to pause the video at any point. Be able to jot down your answers. I'll walk down the stretch here just a little bit more, just so you guys can get some more evidence for your answers if you need more. All right, guys. And that's the end of our little Paradise Creek walk.
Hey guys, so hopefully you just finished watching the tour of Paradise Creek. So I just wanted to go over a couple of the questions after doing the tour questions. So just a reminder, on page 203, you have 2 meters down for Paradise Creek in your table. Then from there, you're just comparing the drainage areas and widths of other sites that you theoretically have. We're going to be creating another scatter plot in Excel with this data, create a trend line, and find the R-squared value. This one you are taking a screenshot of and adding it to the bottom of your lab assignment. So if that means that you have 2 separate files you upload into the BB Learn assignment submission, that's totally fine. Or if you have any problems with that, of course, just let me know. Question 16 and 17, you're just using your trend line equation, which is the linear regression equation, right, or y-intercept. So then you plug in your drainage area for X for question 16. And then for question 17, you're doing the opposite. You're plugging in your stream width, which is 10.65 meters, and for Y, then solving for X, right? So if you think about the rise over run and your data set that you're using, that's what both of those are representing. All right, so the other part is question 18 and 19 for your, like you're basically calculating what the discharge of a stream would be depending on the area of the stream that you're using and everything like that, and the velocity, right? So there's a lot of different factors you have to think about for what the discharge of a river is going to be, right? So anyway, so for question 18, I'll just run through it real quick just so you guys are familiar with how to do it. So nobody should get question 18 wrong, right? So the equation itself is just at the top of page 203. So it's just discharge equals area times velocity, right? So for question 18, we are given that the stream is 3.9 feet deep, 5.2 feet wide, and the water is moving at 15.63 feet per second. So we have to calculate our area, right? So we know that it is 3.9 feet deep, and we're going to multiply that by 5.2 feet wide, right? That's our area. And we're going to multiply that by our velocity. So we know our velocity is 15.63 feet per second. So that's how fast our water is moving in our stream, right? So we then calculate all of that out. To figure out what our units are going to be, we have to remember that all of these units are representing just a power of 1, right? So this is definitely feet to the power of 1, feet to the power of 1, feet to the power of 1 times seconds to the power of 1. So when we're multiplying our exponents, just a reminder, we add those. So we'll get our answer, which I'm not going to calculate out for you guys. So you guys have to do one part of the problem, and then you're going to do feet cubed per second, right? So we're adding 111 per feet. So it's cubed per second because we only have 1 second, right? So it's still technically being the power of 1, but we don't have to write power of 1. So hopefully that makes sense to you guys. Question 19, you're just taking your answer from question 18 and multiplying it by 7.48 gallons to figure out how many gallons per second is flowing through the cross section, right? Because we're given that 1 foot cubed equals 7.48 gallons. So just make sure you show your work for all of these problems and everything, because that is part of the points that you get. From there, you're looking at a hydrograph. So basically, it's just representing rainfall event and what that is doing to the river's discharge downstream from it, right? So our the amount of rain that we get is going to directly impact our stream systems, right? So the breakdown of a hydrograph is on page 208. The lab itself does a really great job of breaking it down. So there's typically not many questions associated with that, but if you do have questions, of course, just let me know. And then question 4F and G of question 25. It's just like basically one very long question for the hydrograph. It's going to be CFS is your units, for those of you that might not be familiar with that. All right. From there, that should be about it. So anyways, if you guys have questions, as always, I'm holding the Zoom meeting during our normal lab meeting time. And if you can't make that and you still have questions, feel free to shoot me an email. And hope you guys have a good week.